right, hello everyone. Gonna get started. So my name's Justin. I'm gonna be talking about Fedimint and solving peer-to-peer connectivity with Iroh. So just a quick note before we get started. We're gonna do like half slides, then I'm gonna do a demo federation setup. If you wanna participate with others in the audience, you can. I have some instructions available at the QR code or at ecash.love/tabconf, so you can look for the instructions there, or you can just follow along here. It doesn't matter to me. Okay, let's dive in. What is Fedimint? What is Iroh? So like I said, just as an agenda for the overview, we're going to do a quick Fedimint overview. What is Fedimint? What is eCash? And we'll talk about this whole talk is just going to focus on the networking side of Fedimint. So we'll talk about some networking challenges in peer-to-peer systems in general. Then we'll get into Iroh, like what is Iroh and what problems does it solve in Fedimint. And then, yeah, at the end we'll do the demo workshop, and the workshop is going to be setting up a federation. I'll do 3 guardians on my computer, and I'm going to do 1 on my phone. So it'll kind of showcase what Iroh can do in terms of connecting peers together. So let's get started. So if you haven't heard of Fedimint before, Fedimint is a open source federated eCash system for Bitcoin, built for privacy and scale. There's sort of different entities in Fedimint. The first entity is maybe like the trusted community members or the guardians. The guardians are the ones that are actually running the federation, and each one of them has a private key to a multisig that actually holds the Bitcoin. There's also users, or we sometimes call them clients. Users then interact with the federation to like peg in and peg out and do eCash transactions. And then the last entity in the Fedimint ecosystem, at least, is the Lightning Gateway. So the Lightning Gateway is kind of what connects Fedimint to the rest of the Bitcoin ecosystem. It provides a like Lightning eCash swap service. So the gateway will pay a Lightning invoice on a client's behalf as long as you pay the gateway eCash. But from an architectural standpoint, the gateway is just another client, very similar to like a phone app like Fedi. So networking-wise, what actually happens in Fedimint? Well, we have all the guardians. The guardians need to talk to each other. So every guardian talks to every other guardian. The clients also need to talk to the guardians. That's how they do the transactions. And then the gateway also needs to talk to the guardians. And that's the reason why it's still in orange, because again, like I said, they're just another client, so they interface very similarly. And then the users also need to talk to the gateways. So there's a lot of different communication happening here. And of course, it's all sort of powered by underlying networking. So taking a step back from Fedimint, what are a narrow subset of challenges that you might face in peer-to-peer systems that we do face in Fedimint? One would be like bootstrapping. How does like everyone in that last picture, how do they find each other? How do like users know how to talk to the guardians? Authentication. How do we ensure that we're talking to the correct entity, that we're not someone's not impersonating like a guardian or something? Encryption. How do we make sure that the data is sent privately and not readable by a snooping adversary? And reliability. Networks are inherently unreliable. They are unstable. They'll drop packets. And how do we ensure that the intended message is sent reliably to the recipient? NATs and firewalls. This is sort of more important in the self-hosting use case, but how do we do a peer-to-peer connection when, say, someone is running behind a NAT or a firewall? This is just a small subset. I know there are other networking challenges in peer-to-peer systems, but these are some of the ones that we've dealt with at least. So going back to that picture, what does that look like in Fedimint? Well, what we use is sort of a traditional web stack. We have DNS, TCP, SSL. The guardians have a WebSocket endpoint, and the gateway has a REST web server. to solve some of those, the authentication and the encryption problem that I just mentioned, we use domains and certificates. So when you set up a federation, these are exchanged during the setup ceremony, and that's so, again, like I mentioned, that each guardian knows they're talking to the correct guardian and that all the data is encrypted. And then the clients, the users in this case, they learn of a peer's domain through the invite code. So in Fedimint, guardians can give out an invite code that looks like a long string of letters and numbers. Clients can parse that, and they then find the domain of the federation. So this might be a little small, but you can see command line, if you decode one of these setup codes, you can see in here a TCP endpoint with a API URL and then a certificate, and that's demoing what I just said. So that's sort of the basic like a basic setup for a federation. That's what we did using the web stack. So this has some pros and cons with setup, right? The traditional web stack. So it's simple. It's been battle tested. DNS and TCP and SSL have been used, all across the internet in different use cases. TLS certificates are becoming easier to deploy if you use something like Let's Encrypt. It's a few lines of config to get a certificate. But it also has some downsides. So the use case for Fedimint, we'd ideally like more users, average users running guardians. And setting up a domain and a certificate might be sort of out of reach for some operators. They're not fully self-sovereign. DNS relies on, the certificates rely on the certificate authorities, and then DNS has some issues with, like DNS cache poisoning and other attacks like that. So there's sort of ways to route around it. There's also some minor points that, like with TCP, there's some things like long timeouts during network switching, and then also things like TCP slow start, which doesn't get up to the full bandwidth right away. And then crucially, at least for the Fedimint use case, it has no NAT traversal. So what this means is that previously, before we integrated Iroh, I'll talk about next, you had to sort of run a guardian on a publicly accessible server. Not a problem for if you have some DevOps skills, but for the average user that maybe doesn't want to use a VPS on Amazon or something, this it's an issue. So solving the NAT traversal for us was a crucial problem. And like I said, it's difficult to self-host if you can't poke through NATs. So what is Iroh, and how does Iroh solve some of these problems? Iroh is a library for peer-to-peer connections that provides a dial by public key API. So essentially, you can sort of create what's called like an endpoint, or node. They sometimes use node, and these endpoints are keyed by public keys. So you can sort of give another peer a public key, and they will be able to figure out where your endpoint is located. So the endpoints, this is the API that Iroh provides for creating connections to nodes, and they're identified as ed25519 public keys. They can be used to accept or initiate connections. Again, in a peer-to-peer setting, no one's strictly a server, or no one's strictly a client. They can do both. But how do you find these endpoints? So Iroh provides a number of discovery mechanisms. And it's essentially what resolves the public key to what's called a home relay. I'll talk about the relays in a second here. They have three main ones. They have the mainline DHT, BitTorrent, distributed hash table, PCAR, and DNS. By default, the N0 runs which is the company that makes Iroh. They run some DNS discovery servers. And the whole point is to find these relays. So the relays are what actually helps establish the connection between two endpoints. In our case, like the two guardians in a Fedimint, or a client and a guardian. These are open source. Anyone can run one. So N0, again, the company also runs some, but you can also run your own in case those go away. And they use Stun to set up this direct connection, which is a hole punching protocol. And then they use Quick for this reliable byte stream abstraction. So once you have the connection set up, you can send data back and forth in a reliable way. So what does that look like? You might have a federation that has the Bitcoin multisig. You have a user client, and then they somehow have to figure out, okay, where's the home relay for the guardian that I want to talk to? This can be, like I said, it can be any mechanism, and they'll eventually find where the home relay is, and they'll connect to that first. The home relay will then try to establish a direct connection using stun, so that if that's successful, it will do this direct peer-to-peer connection. Now, one of the cool parts about Iroh is that it can actually fall back. So say that doesn't work, it will actually fall back to what's called a relay connection. Relay connection, all the data is still encrypted, so it's they're not snooping on the data that's going over it, but it's sort of like a fallback mechanism if the direct connection doesn't work. Okay, so looking at Iroh, some of the pros and cons as well. The big one is the hole punching. The hole punching is what makes self-hosting and Fedimint possible. No domain certificates, so we kind of got rid of that necessity, and now more average users can maybe deploy these things. It uses Quick for efficient, reliable, multiplexed byte streams. Quick is the new transport layer of HTTP3, so it's becoming more and more used now on the web stack as well. And then, like I said, it has this graceful degradation from direct connection to relay connection. So the whole idea of Iroh is that it's peer-to-peer that just works. You can you don't need to know the details behind the hole punching. They'll establish it for you. And then, yeah, it has these discovery mechanisms that are censorship resistant, so you can establish the connections. So there are some downsides. It's a newer library. We've gone through some growing pains in implementing it, and it does provide some additional complexity. Iroh is having a 1.0 stable version released hopefully later this year. They're currently working towards that. Then they have a v35 as their current stable version. There is a little bit of overhead when creating an Iroh endpoint. We've been through that, trying to make sure we share the endpoints as much as possible. And then privacy is so the IP addresses when you connect to a relay are exposed, so relays can potentially figure out like who you're connecting to. And then also it's a direct connection, right? So like clients, when they're talking to guardians or at the gateways, those are also your IP address will be exposed in that. And I'll talk about privacy in a second here. So like I said, the guardians can observe the IP addresses. This is the same model as the previous web stack using TCP, but it's potentially more sensitive when using Iroh. And the thinking being, like, if someone's hosting one of these things at home or on their home network, in that case, they're actually exposing their home IP address rather than, say, running on a VPS, which would be like a IP address from Amazon or something like that. Relays can observe IP addresses, but they can't observe the traffic. It's encrypted because Quick is always encrypted. And it's that model, when it's a relay connection, not the direct connection, is sort of similar to oblivious HTTP. It's like the relay can see that there's a connection. It doesn't necessarily know like what it is because all of the traffic is encrypted. Towards the ideal solution here, we're looking into that. It's obviously slower and less reliable. We have tested Iroh over VPNs. I've been running a Mulvad MutinyNet Federation for a while, and it's been very stable. And then Iroh over this Onyx user space Tor service does work, but like I said, it's still early. We need more testing there to make sure the reliability works well enough for Fedimint. So what does this enable us to do? So Fedimint plus Iroh, essentially, in contrast with the traditional web setup, instead of exchanging the WebSocket endpoints, we now exchange the public keys. So that's what, in a Iroh federation, that's what a setup code looks like. You can see there, instead of a certificate, it's now Iroh public keys. So this allows Fedimints to be self-hosted. You can host it on your own infrastructure at home. or you can still run it in the cloud, or you can run it on one of these node-in-the-box solutions. So we currently have a Start9 package that you can sideload, and then we have an Umbrel app as well that you can install. We also have a Docker Compose file. If you're familiar with Docker, you can very easily in a few clicks get a Guardian running. And again, one of the cool parts about Iroh is that because the networking setup is fairly seamless, you can kind of run on anything. And so we also have an Android app that I would not recommend for production use, but it does work to set up a federation. So that is what I'm going to be doing in the demo. So I'll try to 15 minutes left. So what I'm going to do is I'm just going to set up a federation using 3 Docker Composes and on my phone. And I'll show that here. If you want to do it at the same time, you can go to ecash.love/tabconf and the instructions are there. All right. So I'm going to switch back to joined. Okay. Okay, I gotta find my settings here. All right. Okay, I got 2 Guardians there. One. Okay, so if you're setting up using the phone, this is what you'll see. It's a very basic UI for, we're just going to do MuniNet. So we'll select MuniNet, click Next. You can link it to your own Bitcoin node, but Explorer is the easiest because we don't need to set anything else up. Then we'll point it at MuniNet API, test connection. Then save that. That will automatically launch the Guardian UI. So we'll do 4 Guardians. 3 of them are in here. So let me set up one on my phone. Okay. I'm going to be copying and pasting a bunch of codes back and forth. So sorry, this is the boring part of the presentation, but it is necessary. Yes, go ahead. All right. Do Guardian 1. Okay. So in a real federation setup, each Guardian would be doing this independently. And you'll notice once I do all 3 here, I'll talk through what we're seeing. So Guardian 3. Okay. Okay, so we have 3 Guardians set up. Each of these codes that you see here is what I showed in the presentation. That's like essentially the connection info for each Guardian. So what we need to do is we need to copy this to all the other Guardians. So copy that here. Click Add. Copy this one here. Add. Okay, 1 down. Okay. All right, so we got 2 on each of them, and then I'm gonna go grab the one from my phone. Okay. Notice that one said phone. And I gotta get these 3. I gotta get these 3 over to my phone now. So go over here. All right, so now we just double check. We got 3, 3, 3. All right, we're good to go. So we'll click confirm on all 4 guardians. Confirm on my phone. Confirm here. Confirm. And confirm. All right, so now it's doing the distributed key generation to set up the federation. And again, the 3 guardians on my computer are trying to talk to my phone as well. All the networking communication was set up using just that code that we pasted back and forth to figure out how to talk to each other. This will take a few moments just for all the keys to be generated and everyone to figure out the connections, and then it should be set up. All right, there we go. So that was successful. So then you can log into your dashboard and boom, it's set up. So the invite code, I don't know actually. We'll have to add that. Oh, I could do that, yeah. I don't know, this one. So that's the QR code for the federation we just set up. If you want to scan that, sorry. There we go. That's not what I wanted. Okay. So yeah, you can join the federation I just set up. You can join that using Fedi or eCash app. You can see here in the dashboard. So this latency box here can show like what connection type it is. So in this case, it's a direct connection between all the guardians, which is kind of cool. Yeah. Yeah, no, that's how it would work. When you come back online, it would like republish to the relay like how to find it. You can keep your relay the same, but it would your IP address would change. And yeah, then the relay would then know how to connect to you, and it would be reestablished. So you can move. That's the nice part about why it works on a phone is that you can use the relays to get the connection back working. So yeah, that would work. Cool. Any other questions? That's kind of the demo. After you do this for Federation setup, you can connect the Lightning Gateway. We don't have time for that right now, but that would be the next step, so you can get Lightning payments. All right, cool. Well, thank you. That's it.